beneath the quiet forests of Wyoming, something has started to move again. Not a monster, not a myth, a supervolcano the size of a small country, and for the first time in years, it's behaving in a way that has scientists watching their screens a little more closely than usual. Because in the summer of 2026, Yellowstone did something it hadn't done in exactly this way before. A hydrothermal explosion tore open the ground near one of its most famous pools, throwing scalding water and rock into the air, staining a river gray for miles. And it happened almost right on top of the one monitoring station built to finally catch this kind of event in the act. Welcome to Infinite Findings, where we uncover the world's most fascinating mysteries, unbelievable discoveries, and untold stories. Today, we're going underground, literally, into the volcanic heart of North America to understand what's really happening beneath Yellowstone and why researchers are calling this moment unprecedented. Let's start with the basics, because to understand what's unfolding now, you need to understand what's been sleeping down there for millions of years. Yellowstone isn't a mountain that spits fire. It doesn't look like the volcanoes in movies, with a smoking peak and flowing lava. Instead, it's a caldera, a vast collapsed basin roughly the size of Rhode Island, formed after previous eruptions so violent they caused the ground itself to cave in. On top of the emptied magma chamber below. Walk through the park today, and you're standing inside the scar of that ancient devastation. Below that scar sits a reservoir of molten and semi-molten rock, fed by a hotspot that has been active for at least 17 million years. As magma pushes upward into a chamber, sitting roughly 4 to 6 miles beneath the surface, the ground above swells, like a chest slowly filling with air. When the magma cools and settles, the ground falls again. Scientists have been measuring this rhythm since 1923, and they have a name for it. They call it caldera breathing. It sounds almost peaceful. It isn't always. 3 times in the last 2.1 million years, that breathing turned into something catastrophic. Eruptions at 2.1 million years ago, 1.3 million years ago, and 640,000 years ago each blasted enough ash, gas, and debris into the sky to bury much of the continent. Evidence from the last of these eruptions has been found as far away as Louisiana. Each time, after the fury passed, the ground swallowed itself, leaving behind the caldera we walk through today. So here's the question that's kept geologists awake for decades. Is Yellowstone simply resting the way it has for hundreds of thousands of years, or is it stirring towards something else? For a long time, the official answer was reassuring. Move along. Nothing to see here, but the last 2 years have added new pieces to the puzzle, and not all of them are so easy to dismiss. It starts with the earthquakes. Yellowstone is one of the most seismically active regions in the country, recording between 1,500 and 2,500 quakes every year. Most are so small you'd never feel them, but scientists watch the patterns closely, because patterns can mean something. In June of 2026 alone, monitoring networks operated by the University of Utah detected 118 separate earthquakes across the Yellowstone region. The strongest was a modest magnitude 2.4, striking about 12 miles southeast of Yellowstone Lake. On its own, unremarkable, but it wasn't alone. That same month, seismologists tracked 3 distinct earthquake swarms, clusters of tremors striking in tight succession in the same general area over just a few days. One swarm alone produced 25 separate quakes in 4 days. Swarms like this aren't unheard of at Yellowstone, but they are one of the signs scientists watch most carefully. Because a swarm can mean fluid, gas, or heat moving somewhere it hasn't moved before. And then came June the 13th. At just after 5 in the morning, instruments in a place called Biscuit Basin picked up something unusual. A burst of seismic energy, a low-frequency acoustic pulse called infrasound. The kind of sound too deep for human ears, but unmistakable to a sensor built to listen for it. Something, somewhere, beneath that basin had just let go. Park staff noticed it first with their own eyes. The Firehole River, flowing from Biscuit Basin all the way to Midway Geyser Basin, nearly 4 miles downstream, had turned a pale, milky gray. 2 new channels of water were cutting fresh paths from the basin into the river. Something had broken open the ground. The immediate suspicion fell on Black Diamond Pool, a feature already known for violent outbursts, including a well-documented explosion back in 2024. But when scientists checked the pool's temperature sensors, the readings didn't match. There was only a small heat blip, nothing like the dramatic plunge you'd expect from a major eruption at that specific pool. So what actually happened? This is where luck, or perhaps foresight, changed everything. In May of 2025, engineers had installed a camera specifically to watch Black Diamond Pool, anticipating exactly this kind of event. And that camera happened to be pointed in exactly the right direction. At 5:09 and 50 seconds that morning, it captured a dark plume of steam erupting not from the pool itself, but from the ground just north of it. At the precise moment, the seismic and infrasound signals spiked. When geologists reached the site the next day, they found the evidence waiting for them. A few dozen meters from Black Diamond Pool, 3 sets of brand new vents had torn open in the earth. Water that had been sitting beneath the surface at or slightly above boiling temperature had suddenly found a path upward and flashed instantly into steam, blasting rock and sediment into the air and sending a surge of scalding water into the river below. This is called a hydrothermal explosion, and it's different from a volcanic eruption in one crucial way. There's no rising magma, no lava, no ash cloud from molten rock. It's essentially superheated water beneath immense pressure, finding a weakness in the crust and detonating outward, like a pressure cooker, finally failing. But don't let the word hydrothermal make it sound gentle. These blasts have hurled boulders the size of small cars, and history has shown they can be lethal to anyone standing too close. What made this particular explosion different wasn't its size. It was actually smaller than the 2024 event at the same location. What made it extraordinary was where it happened. This explosion occurred barely 300 feet from the newly installed Biscuit Basin monitoring station, the very sensor network built after the 2024 blast, specifically to catch a future explosion in the act. For the very first time, scientists had a real chance of recording every precursor signal, every warning sign, in the moments before the ground gave way. That data is still being combed through today, and what researchers learned from it could reshape how Yellowstone and hydrothermal systems everywhere are monitored for decades to come. But the earthquakes and the explosion are only part of the picture. There's a second story unfolding. This one written not in tremors, but in rock buried miles beneath the surface. Earlier this year, researchers published findings that startled even seasoned volcanologists. Using advanced seismic imaging, they identified pockets of magma sitting between roughly 4 and 15 kilometers beneath the caldera, an amount of molten material up to 4 times greater than what was released during Yellowstone's largest ever eruption. Read that again. 4 times more magma detected than what powered the most violent explosion in Yellowstone's history. Before you brace for the end of the world, take a breath, because the story gets more reassuring the deeper you dig. Researchers also found hot magmatic rocks acting almost like a lid, trapping that magma within the crust rather than allowing it to rise. And crucially, the chamber overall remains only 5 to 15% molten. For an eruption, scientists generally believe that number would need to climb dramatically higher, likely past the 50% mark. Right now, Yellowstone's furnace is nowhere close to full boil. There was one more twist buried in that research. Scientists identified a specific pocket in the northeastern portion of the caldera as the area most likely to host any future eruption should one occur. It's not full, it's not primed, but of everywhere beneath that vast landscape, it's the region scientists are now watching the most closely. So where does that leave us? Earthquake swarms, an unprecedented hydrothermal blast recorded in extraordinary detail, newly discovered pockets of magma, far larger than expected. It sounds on the surface like a countdown. It isn't. Every official body monitoring Yellowstone, the United States Geological Survey, the University of Utah, the University of Wyoming, and the broader Yellowstone Volcano Observatory Consortium, agrees on one thing. As of this year, Yellowstone remains at normal alert status. Ground deformation measurements show no significant uplift or sinking of the caldera since the start of 2026. The system, in the language scientists use, remains at background levels. And here's the detail that should actually bring some comfort. Scientists estimate that if Yellowstone truly began moving toward a major eruption, they would likely have weeks to months of warning beforehand, not seconds, not days. The annual odds of a supereruption are estimated at roughly 1 in 730,000. You are, statistically, far more likely to be struck by a car crossing the street than to witness Yellowstone unleash its full fury in your lifetime. But here's the twist that keeps this story from ending neatly. Some of the most unsettling research on supervolcanoes doesn't come from Yellowstone at all. It comes from Indonesia, from a supervolcano called Toba, the site of humanity's closest brush with a catastrophic eruption roughly 74,000 years ago. When scientists studied the geological record leading up to that eruption, they expected to find decades, maybe centuries, of clear warning signs building toward the climax. They found almost nothing. The data suggests that a supereruption might not announce itself with a long, dramatic build-up at all. It could emerge with unsettlingly few precursors, offering little indication to the people or the instruments watching from above. It's a sobering thought, and one reason scientists refuse to grow complacent, even while insisting there's no cause for panic today. If the unthinkable ever did happen at Yellowstone, the scale would be almost impossible to comprehend. Modeling from USGS scientists suggests a worst-case eruption could blanket land within 1,500 kilometers. Cities like Denver and Salt Lake City under many meters of ash. Farther out, Chicago, San Francisco, even Winnipeg in Canada could see a few centimeters settle over rooftops and roads. Ash acts as a magnet for moisture in the atmosphere, meaning the fallout wouldn't just choke the sky, it could trigger torrential rain, turning ash into thick, clogging mud across huge stretches of the country. Some models suggest global temperatures could drop by several degrees for years afterward, reshaping harvests and climates across the planet. It's the kind of scenario that sounds like science fiction, and for now, that's exactly where it belongs. Fiction, not forecast. Because the story unfolding at Yellowstone right now isn't one of impending doom. It's a story of a landscape that has always been alive, always breathing, always shifting in small, fascinating ways, and of scientists finally getting the tools to listen closer than ever before. The June explosion at Biscuit Basin wasn't a warning of the end, it was a gift. An unprecedented dataset capturing the seconds before the ground gave way that could help researchers understand and someday predict hazards that have puzzled them for generations. Millions of people still walk Yellowstone's boardwalks every year, watching Old Faithful erupt on its near-clockwork schedule, marveling at the rainbow colors of grand prismatic spring, unaware that they're standing directly above one of the most closely watched geological systems on Earth. And that, in the end, might be the most remarkable part of this story. A supervolcano capable of reshaping the continent, sitting quietly beneath a national park while families take photographs a few feet from its restless breathing crust. Yellowstone isn't erupting. Yellowstone isn't waking up in the way headlines love to suggest. But it is speaking, in tremors, in swarms, in sudden bursts of steam, and for the first time, scientists are finally positioned to listen to every word. If you found this journey beneath America's most famous supervolcano as gripping as we did, make sure to like this video. Subscribe to Infinite Findings for more deep dives into the planet's greatest mysteries. And tell us in the comments which hidden wonder we should uncover next. Thanks for watching, and we'll see you in the next discovery.